Hey, welcome back. Remember, we were trying to make sending packets resilient to failure, and we kind of messed around a little bit with a naive approach, and then we had a better solution using recover and recover with, but that was unsatisfactory because we returned the wrong error message in case something did go wrong when both calls would go wrong. All right, so what we're going to try to do now is we're going to write a better recovery combinator, and that's called fallback to. And what that tries to do is it will try to execute the computation so that kind of, if this, it will try to, this is defined on future of t. So what it will do is it will try to run this future. When that fails, it will try the fallback future. But if that fails, it will return the error that the first failure was. All right? So we first try to run the this. If that succeeds, we're done. If that fails, we try the fallback. If that fails, we know that the this failed, so we return the error message, the error from that one. All right. If we had that function, then we can define send to save as follows. We first try to send it to Europe. If that fails, we fall back to sending the message to the USA, and then we recover by getting the Europe error message, because that's what the fallback to gives us, and then we can turn that back into the byte array. All right, so this looks much better. So this fallback to is a very nice combinator that's very useful. So how are we going to implement that? Well, it's surprisingly simple. You could have noticed it yourself when we looked at this code here, because instead of getting the US error, we would just return the Europe error, and in this case, that is represented by this. So fallback to is simply defined as this recover with. In that case, we just can throw away the error message, and then we try that, and if that fails, we recover with this, and this is a future, but we know that it failed, so everything goes right. So look at this code for a few seconds, and you have to admit that this is beautiful. All right, so you try this, if that fails, you try that, and then in the end you say, okay, if both fails, then we just return this. Now, the reason we introduced futures was that we had computations that took a long time, and we didn't want to block on them. We didn't want to block several years in human time for a computation to finish. So that's why we had futures where we passed a callback. Now, sometimes when you're testing code, you still want to block, because you just want to print something or whatever. So this code is dangerous to use, but it's useful for testing cases or when you're writing small sample scripts. So there's this special trait here, the awaitable, and that has these two functions in here that will allow you to block on a future with a kind of timeout duration. So don't use this in production code. If you see one of your colleagues use this while you're doing a code review, you should scream bloody murder. You should never use this, only in small demos and little scripts. Right, so for example, what we can do here is we can read from memory, send the packet back, we get the confirmation, and now we want to print the confirmation. So what we can do is we can say we want to wait at most 2 seconds, and now we can, we get an array of bytes, and we can turn that into text. So, you should always, once you're asynchronous, you should never ever block, except, when you're debugging or doing little scripts, okay? So promise that to me, never block when you have an asynchronous computation. And we will see the same when we're doing observables. There we have a similar mechanism to allow blocking, but that's only for convenience, but never use this in production, because once you block somewhere in this whole pipeline, you might have, have not used asynchrony. Okay, so the reason that you introduced futures was because there was latency. As soon as you introduce blocking, you're destroying all of that. So promise me one thing, don't do that, okay? You're introducing futures, and now you're stuck in future land. Good. There's one nice thing here in Scala that I have to show you. These are the postfix operators. So when you want to kind of create a duration for a number of seconds or minutes, when you import scala.language.postfixops, then you can write a number followed by minutes. So it looks very much like units of measure. So 5 years, that is 1826 minutes. All right, good. So thank you very much. This was the lecture on combinators on futures. In the exercises, what we will do in the homework or the labs, what we will do is we will show you a different design for futures, and then you will have to implement your own combinators on those. So thank you, and see you next time.